Yeah, good evening. We proceed. If you cannot hear me, please let me know. But I hope I'm audible. Uh, I just want to give to extend a little bit the topic of foundations and to do some some additional explanation to let you see how all the formula we've driven can be applied. Sometimes we have eccentrically loaded foundations, which this is a fact we established from the previous classes. So as with the base of retaining wall, foundations are subjected to moments and in addition to the vertical loads as shown in figure 8, this figure. I also have to say that all the figures used here are from the foundation book, Foundation Engineering by Braja Das, and I have left the notification. I mean the numbers. I did not want to interfere because if you are going to refer, if you change, the text may not agree with the new naming. So if because in this text now this would be figure 1, but if I start renaming, that would be a little tedious. So I've left them the way they are, and I've just lift the name and put in the text like that for consistency. But all the figures are from a Foundation Engineering book by Braja. So anyway, sometimes we have a moment. I think this is the most realistic case, but you have done enough structural mechanics to know that the pressure would be determined by P divided by A plus or minus PE times eccentricity, right? PE uh, over Z. Now this equation can also be written as sigma plus or minus m times I. You should have done enough uh, over y, either y or x. If the moment is in the x direction, then you divide by y. If the moment is in the y direction, then you divide by x. You should have known this from the from structural analysis. But for rectangular surfaces, actually I is simply BD cubed over 12. Now, if you are talking about a unit B, then I is just D cubed. I would just be D cubed over 12. But the Z, the Y or the X, either way is D over 2. So times 2 over D. Therefore, you get D squared over 6. So this would be, so actually that would be, the stress would be P over A plus or minus M, but I divided by Y is already you've seen D squared over 6. So you can see why this equation sigma P over A plus or minus 6m, you can see y over d squared, but if b is not 1, then you have to include the b there. That's the point. So that's all we're trying to do here. Q over ba. So so in the what my explanation, q equals p, and of course b l is a. So you can see why this. So the maximum of these forces could only be, from what I've said, I think is plus or minus. So it says obviously that q max can be either q over bl plus m divided by b uh, d squared. This is 6, sorry. And then there, of course, sigma mean would be q over bl minus 6m over bd squared. Anyone with a problem with this? Should be fairly straightforward, should be simple. If you do have a question, please feel free to raise.